What are biogeochemical cycles? These are pathways by which chemical substances move through biotic and abiotic compartments of Earth.
Examples of these cycles are the nitrogen cycle, the carbon cycle, the phosphorus cycle, and last but not least, the water cycle.
In this short video, we will discuss these cycles in detail and how these substances move through our environment.
Firstly, we have the nitrogen cycle, presented by Mariah Masha.
Nitrogen is essential to living organisms because it is needed to create amino acids. Step 1. Nitrogen-fixing bacteria such as cyanobacteria take atmospheric nitrogen and convert it to ammonia or NH3 in a process known as ammonification. Step 2. Other bacteria such as Nitrosospira take this ammonia and convert it to nitrites and nitrates. This step is known as nitrification. Step 3. These nitrates and nitrites are absorbed by plants through the soil. Step 4. The plants make proteins with these nitrates and nitrites that are eventually consumed by animals, who use these compounds to make their own proteins. Step 5. After these animals die, decomposers break down the nitrates and nitrites back into ammonia so the process can begin again. There are a few bacterium that can also transform ammonia back into atmospheric nitrogen in a process known as denitrification, but this is less common.
Next, the carbon cycle, presented by Lucas Gatti.
Carbon is an element found in many forms and locations within our Earth and atmosphere. It is found abundantly in living organisms. The key molecule that makes up our bodies, such as proteins, carbohydrates, and DNA, contain carbon as a major component. Carbon is also found abundantly in our atmosphere in the form of carbon dioxide or CO2. Additionally, carbon is also trapped within the Earth in the form of fossil fuels. We have a fixed amount of carbon on Earth and in the atmosphere. That means that all of the carbon we have on Earth and in the atmosphere is the same amount we always have. And so, when new organisms are being formed, carbon is needed to form those key molecules, such as proteins and DNA. This is where the carbon cycle all comes in. Step 1. Carbon enters the atmosphere as carbon dioxide, from respiration, breathing, and combustion, burning. Step 2. Carbon dioxide is absorbed by producers, life forms that make their own food, an example, autotrophs like plants, to make carbohydrates in photosynthesis. Step 3. Animals feed on the plants, thus passing the carbon compounds along the food chain. Most of the carbon these animals consume, however, is exalted as carbon dioxide. This is through a process of respiration. Animals and plants then eventually die. Step 4. The dead organisms are eaten by decomposers in the ground. Carbon that was in their bodies is then returned to the atmosphere as carbon dioxide. In some circumstances, the process of decomposition is prevented, and the decomposed plants and animals may then be available as fossil fuels in the future for combustion. This cycle ensures that carbon is able to be used again and again, which is important because this element is essential to many chemical processes and is a fundamental building block of life.
Next is the phosphorus cycle, presented by Emily Campbell.
Phosphorus is an essential nutrient for animals and plants. It plays a critical role in cell development and is a key component of molecules that store energy, such as ATP, DNA, and lipids. Insufficient phosphorus in the soil can result in a decreased crop yield. The phosphorus cycle is slow compared to other biogeochemical cycles such as the water, carbon, and nitrogen cycles. In nature, phosphorus is found mostly in the form of phosphate ions, phosphite and phosphate. Step 1. Phosphate compounds found in sedimentary rock leaches into surface water and soil as the rock weathers. Volcanic ash, aerosols, and mineral dust can also be significant phosphate sources, though phosphorus has no real gas phase, unlike other elements such as carbon, nitrogen, and sulfur. Step 2. Phosphate compounds in the soil are taken up by plants. Step 3. Phosphorus is then transferred to animals when they eat the plants. Step 4. When these plants and animals excrete waste or die, phosphates may be taken up by detrivores or returned to the soil. Phosphorus containing compounds may also be carried in surface runoff to rivers, lakes, and oceans where they are taken up by aquatic organisms.